Morning guys, Lenny and Dynomite Diesel Products. So Mitch, what are we going to talk about today?
We're going to talk about a new street 12 valve that we're going to build that's a little bit different than what you would normally build.
Well, truth is like I've still got 3 second-gen P-Pump trucks, and I like P-Pumps a lot. I've always enjoyed them. When I first started working on these trucks, that was pretty much what I spent most of my hours trying to figure out. And then I found a few of them that were in really low mileage, really good condition, but they've always had some challenges. So on my right over here, I've got a maroon truck. It's a 2-wheel drive, 94 standard cab. And that truck showed up here for $4,000, 0 wiring harnesses, 0 engine, 0 transmission. And believe it or not, there's actually 4 different wiring harnesses that were available for that truck back then, and we had to buy 3 of the incorrect ones before we finally found the correct one. And then of course it was, built in 1994, so we had to fix it and doctor it up and get it back to running. And then we rebuilt what we would call just a stock, just a good stock motor, ARP studs, Hamilton cam, nothing crazy, nothing too fancy, just a good, tight, balanced and blueprinted motor. Had good piston protrusion in it. Everything ran really great, but one day the steering column, the shifter in this truck's a little bit sloppy and a little bit loose. So I was on the dyno and of course had the back tires strapped down to 50-inch rollers with 8,000 pounds of rotating mass and lots of traction. It was going about 90 miles an hour, and I went to pop the truck into neutral and hit the brake on the dyno. Well, I hit the brake on the dyno, but unfortunately I went past neutral into reverse, and that was it. Motor stopped. And at that point I got out and there was coolant all over the ground. So I knew that I made a lot of cylinder pressure and immediately went to pulling the head off it, threw a new head gasket back in it, put it back together, and thought, this will run. And it's not ran that good ever since. And the other day, it was parked outside the shop here and it was cold, and I had to start it with ether. And I thought, this motor had 25 thousandths compression, stock pistons. There's no way that it should be this hard to start when it's cold. So assuming that I've got bent connecting rods, we decided to pull the motor out of this because it has some pretty good parts, and we have a better donor motor for that truck. But with the things changing and evolving with what we've been doing with 12 valve stuff, pilot hole technology in the injectors, 12.5 millimeter pumping elements. So we've got P&Bs that are 12.5 millimeters now, and they work really, really good on the stand. But we don't have an engine worthy of testing this.
Not even close.
So gonna take an SXE 76 and blow that into an SXE 363 because it's a pretty common, easy to get, easy to obtain.
Sure. Yeah.
A lot of guys, use something similar to that. And we're gonna do some cool stuff with it. So, Mitch, what do you got in front of you over there?
So I've got these really cool Wagler rods. And these are Street Fighters, and these, for what we're gonna do with a 6.7 crank, these are 80 thousandths shorter to make up the difference in the 5.9 to the 6.7 crankshaft throw.
So we are going to use a 6.7 crankshaft, which basically entails removing the straight cut drive gear off the front, putting the helical cut gear on it from a 12 valve, and then we'll tack weld that on, make sure it stays in place. But there is 80 thousandths extra throw with the 6.7 that a 5.9 doesn't have. And I've done this combo before and it worked out really well. It spooled the charger a little harder, especially down like low. And I'm trying to build something that acts like a common rail, but still has that classic sound of a P7100 pump.
Exactly, yep.
And there's a ton of these trucks on the road. They were pre-emissions trucks. There's a bunch of guys that have done them horribly incorrect, and they think they're fun because they make a number.
Yeah, and like we've talked about before, like just because you're making a number at, let's say 3,600 RPM, you don't use it there. Like you're driving it down low, and that's the goal of this engine, is to make gobs and gobs of torque down low, be actually fun to drive, spool those chargers up, And just be like, it's just going to be a torque monster. That's the idea behind it.
Yeah. With common rails having variable timing based off of throttle input and vehicle speed and torque load and everything else, it's really tough to drive a common rail for 15 years and then jump into a P-Pump truck, which the stock cylinder heads aren't near as good as a common rail head.
Oh God, no.
Variable timing's a big deal. Variable injection pressure's a big deal. You get used to driving a common rail with just tons of throttle response and the ability to still make a lot of horsepower upstairs. And with what we have on the 12.5 millimeter P&Bs, we can increase timing about just 8.5 to 10 degrees of timing from like 15 degrees of rack travel up to 21 degrees of rack travel. So Kevin, our buddy that's running the pumps for us, has actually done and documented that for me. And we're trying to figure out where we're going to run this thing at max travel. It's probably going to be right around 19 millimeters of rack. And right now we will give you just a B-roll shot of the flow between the standard 215 P&B and our 215 P&B with the 12.5 millimeter DLC coating on it. And there's a big difference in flow. So because of that, I'm assuming we're probably going to be like a stage 4 injector on this thing, if not maybe a little bit bigger.
Yeah, that would be my guess.
A bigger surface area of the plunger is going to give us a better injection rate, especially at higher RPM. So I'm not afraid of going too big on the injectors because the plungers are going to be pretty wicked. So we've got Wagler Street Fighters, 80 thousandths shorter. That should give us piston protrusion about stock-ish.
Yep.
So we'll put this thing together once. Depending on this deck and where it's already been decked to, we're shooting for about 25 thousandths piston protrusion. And we may have to adjust deck height by putting it together, measuring piston protrusion, tearing it back apart, cutting the deck, or possibly modifying the pistons a little bit. So we will show you that as this progress and build goes along. And then we've also got Powerdriven's head, and this is their stage 1 tow port head. Will tells us this thing exhaust valve on the exhaust side would flow about 139 CFM.
Yeah.
And this head's, where is this head at?
They got it 178 CFM.
So it's a really big increase on the exhaust side.
Oh yeah, for sure.
And guys, with these heads, the intake's not really the biggest restriction. You're trying to you can make more air by just increasing boost pressure. But trying to get the air to leave the motor and become a very efficient air pump is really going to be critical. So the reason we did this head is because it's already got good springs in it. It's got good retainers in it. Will says that I can run this thing to 4,000 RPM pretty reliably. And with, a 40 CFM bump, and he claims there's a 22% increase in swirl.
Yeah.
Which the swirl is the mixing of the fuel to get the fuel to burn and turn into energy.
And that makes a big difference on your low end. That's where your swirl comes in.
It's going to be, I'm very excited about this head.
Yeah,
I'm very excited.
definitely.
And we haven't decided what we're going to use for a head gasket yet. Might be fire-ringed, might be O-ringed, but I'm going to wait. This head is perfectly flat, so we can do all the machine work here. We've got the coffee grinder, tool here. If we decide to put piano wire in there and go O-ring, then we're going to keep that at about 4 to 5 thousandths protrusion. And we'll use ARP 625 head studs, pull them to 160. We would then bore the block to fit the pistons using a torque plate. That way, as you pull ARP 625s, 160, 165 foot-pounds, it actually opens up the bottom of the bore because you pull so much clamp load up top, and then it tightens the top of the bore by about 1 thou or 2. So it's really important that if you're going to do this kind of thing with that much clamp load, you put a torque plate on it and let the machine shop do the final hone work while it's under stress, because that's how you're going to use it, is under stress.
Yep.
So just a couple little tricks.
I actually watched a video the other day, the machine shop, and he took his snap gauges and put it in a cylinder, and then let it just sit there and hang, and he actually grabbed the block with his hands and was able to push it, and the snap actually falls out of it.
Seriously?
Yeah, it was crazy. You wouldn't think that
That's
just
wild.
by hands you could move it, but
That's wild.
That's how big a difference a torque plate can make getting your motor right.
Well, that brings me to another thing. We're not using a big bore piston in this because I want this to be very reliable. I want it to go down the street for a very long time. And the more metal we take out of the bore, the more fragile the block gets. And a Cummins 6.7 block is a lot more durable than this old 24 valve stuff, or 12 valve and 24 valve stuff. So we're not going to use a big piston because of that. I'm trying to leave as much iron in it as possible and still try and get this thing to make that 750 to 800 horse mark. And my challenge to this is we want it to be 750 like smoke free. I'd like this thing to get in about 22 degrees timing, start the truck, drive it around, and let it be amazing to drive. And then as rack goes up, we're going to gain timing. We're going to get somewhere around 28, maybe 30 degrees timing out of it total at wide open throttle, which will really help manage exhaust gas temperature. And still, when you come off of throttle, you're going to go back down to 20, 22 degrees timing, wherever you set your initial static timing at, and it's going to start and drive really good off the bottom end. So that's one of those features about this 12.5 millimeter plunger that we just had made that's really going to help out guys on the street. So, pump. We are going to use 12.5 millimeter plungers and barrels.
Yeah.
They do pump really well. They are DLC coated. They do have variable timing. We're going to use our 5K governor springs. And so the 5K governor springs don't use any sort of shimming underneath them other than the idle spring gets shimmed. So for those of you who have never installed our 5K governor springs, basically we're going to tell you to put a 30 thousandths shim under a 160 style idle spring initially and go in about 4 clicks. Try and drive it. If you get all the RPM out of it you need, then you're in good shape. And if you need to go in one more click to that 5th, then that will give you more RPM. It may mess up your idle. And on the side of the injection pump, there is a idle start stop. And that could be adjusted to help you get that idle back to where it's needed. But I've done that several times before. The truck that this is going in has remote start. So when this is done, the goal is to let that truck start on a cold day parked outside with the push of a button so I can enjoy a cup of coffee while the truck's warming up.
Yeah, we don't want that putting your toe on the pedal to start it kind of deal. It needs to just start, just bump the key, fires right up. That's what we're looking for.
That's the goal. That's the goal. We're trying to build something and show you guys that if you do things, you know, I've been doing this a very long time and I've done things wrong a lot of times. So some of the tricks that you're going to, you know, kind of learn along the way, feel free to use them. If I'm showing you this stuff, it's because I know it and I trust it. Another thing about these motors is the oil squirter in the bottom that shoots at the piston. The hole is just a little plastic jet. And the hole will give you a lot of pressure, engine oil pressure, but these things don't lack for oil pressure anyway, but it's not a lot of volume. So way back in the day, we would stick pistons in these things pretty easily. And I discovered that if I took a drill bit, like a 90 thousandths drill bit, shoved it through that plastic squirter, cleaned up everything and made sure I got all the plastic shards out of it, installed it in the motor with a 90 thousandths hole, piston sticking issues really did go away. Did I lose oil pressure? Yeah, I lost about 5 pounds of oil pressure, but still on a cold morning with 1540, you're gonna make 75 to 100 pounds of oil pressure anyway. So we don't really recommend you try and drive down the street with 100 pounds of oil pressure no matter what. Yeah. Well, Mitch, without further ado, sorry guys, I got a winter cold. Without further ado, let's tear this thing apart.
Let's do it.
Get to the machine shop. All right guys, watch along. So, guys, when you're using ARP head studs, in the instructions they'll tell you that that rocker bridge right there needs to be notched down, and that's true, but I like to cheat and I just notch out the inside of the valve cover. So camera guy, if you'll get a picture of that please for me. Naughty. That little guy right there would normally be cut down. I think they tell you about $100 or something, but
just do it, just cut them. ARP supplies a washer for a reason.
Come on. Oh, there we go. Yeah, that was snug.
Yeah.
So guys, that was, like, obviously, whoever decided to put this head on doesn't know the trick, but I always put head studs in all the way to the bottom, and then I pull them out 360 degrees. So just one full revolution away from the bottom, because if you shove that stud clear into the bottom of the block, and as you're torquing on it, you try and drive it into the bottom of the block, you're gonna end up fracturing the stud in the middle, and it will cause you grief later on down the road. You'll have a stud in there just kind of rattling around. So, this is unique. I know there's a lot of different fastener companies out there, but ARP's been around a long time. They're good people. I've never had any problem with their product, so I keep using ARP even if it costs a little bit more. I'm into putting it together once and trying to leave it together as long as possible. So when you get one that's real stubborn, doesn't want to come out, you can place a nut all the way down on the threads, and I'm just going to use ARP's hardware, if I can get it on. It doesn't seem right. What size is that? What a 19. Okay, so I got one nut on there upside down. I'm going to run this nut to that mating face and just jam them together good and snug. And that was a little excessive. Okay, so real quick, close up. Took one of the nuts face up, one of the nuts face down, ran that directly into that to create the friction, and then I used my pliers on this nut to break it free. So if you ever have to fight that, don't mess up your Allen bits, just do this instead. All right, so what I'm looking at is I'm looking at the combustion gas that's been happening outside of this firing. So I'm curious to see how much O-ring is actually protruding out of that head, because this gasket was leaking pretty bad. So that's kind of a bummer, but here we are, we're gonna fix it. So, and this head was, you know, like we show you there, we got O-rings. It's got some like springs from Pack Brake, like 60-pound valve springs. We got a lot of impression. So our coolant was staying where it was supposed to stay. So we had, and you can see that the gasket did crush. So we can, I'll measure it here in a minute. But, and we've got good impression on the factory firing. Mitch, you remember when you said this thing always wanted to leak oil no matter what gasket it was?
Yes.
Well, when she's got a blown head gasket, they'll make cylinder pressure in the crankcase like that.
I spent hours trying to seal this stinking thing up.
And now we know why.
Yeah.
You know, we should measure protrusion real quick.
Okay, you want to? Okay.
I think we should, yeah.
We can do that. We have
Yeah.
the ability. Pop these off real quick.
$31 and $30 and $30. So basically, we're going to
30 and a quarter.
30. You roll that just a little bit, bud, so it's more flat.
Which one?
The
Oh, I can. Oh.
all the control
there.
Man, that's like 32. 31. $31. 31. Now obviously I'm measuring a little bit of carbon too, but
31 and a quarter.
pretty impressive. You guys will hear me talk a lot of smack about people using like roll-lock wheels and things trying to clean block surfaces, because you're only given a couple thousandths of an inch for like deviation on the block surface and the head surface. And if you got a roll-lock in there and you're going to town, 100 pounds of air pressure behind it, and that thing's spinning at 13,000 RPM, you're creating little craters and what have you that are a couple thousandths deep, no matter what. And you just kill the ability for that head gasket to lay flat. So, a long time ago, discovered these like super scrapers, and they come in 3 different thicknesses. I got like a 2-inch, a 1-inch, and I don't know, probably a half or a 3/4, I guess. So you can get in and do some different detail work with it. But it's just a piece of carbide. Keeps everything nice and flat. You don't want to get real crazy and start gouging stuff. But this will prevent you from head gasket warranties and wasted labor. So if you don't have one, buy one on Amazon, or your local machine shop might have them. Order them on
Tool trucks got them.
Tool trucks have them now?
Oh yeah.
Back in the old day they didn't.
Yeah, tool trucks have them now.
Cool.
The old snap-on guy carries them.
Can you do me a favor and just drop those 2 pistons a little bit low? Perfect. Thank you.
Yeah.
Check out the big brain on you. $30.
Ooh, I like it.
Okay. So what's that mean, bud?
Probably have to take a little bit off. We're shooting for 25.
So this block.
Are we going to reuse these pistons, or are we going to go?
I think we'll use these pistons.
Okay.
Like, keep it cheap, keep it real. Everybody owns a set of these. Mm-hmm. So let's pop the dowels out. Let's give this to the machine shop and let them surface the block to clean it up.
Yeah.
And if they pull 3 off, then we'll pull like 8 off.
Yes.
And if they pull 5 off, then we'll pull 10 off.
Yep. I like it.
So that way we get our 25 out of the deal. Okay. Well, let's tear it back apart.
Yeah.
Let's make a phone call.
Yeah.
And guys, be back to you here in a little bit. Might take a field trip out of the machine shop.
Ooh, field trip.
Field trip!